Welcome back, pre-calculus students. Just like last time we looked over some basic ideas of angles, we're going to review some basic triangle information before we start introducing any wholeheartedly new material. Given any triangle ABC, let's notice a couple of things. First of all, angles are written in capital letters, side lengths are written in lowercase letters, and the side length A is always opposite of A, B is opposite of B, and C is opposite of C. Just a little indication, so when you look at a picture, you kind of figure out whether or not you're looking at an angle or a side length just based on the capitalization. The sum of any angles, in this case A plus B plus C in any triangle, remember, is 180 degrees. If you combine the length of any two sides, it's always going to be greater than the third. What that would mean in this case, this triangle, A plus B would have to be greater than C, B plus C would have to be greater than A, and C plus A would have to be greater than B. If these aren't true, you know you're not looking at a triangle. The larger the angles are opposite of larger sides. So if angle C is greater than angle B, which is greater than angle A, then we know that side length C will be bigger than side length B, which will be bigger than side length A. Another way of saying this, you can think of isosceles triangles. There's a similar idea that in isosceles, if these two, A and B, are equal, that means the two side lengths would also be equal. But basically the relationship is if its side's bigger, that means the angle opposite of that will also be bigger. Next. Similar triangles, remember, similar triangles have corresponding angles that are equal and sides that are proportional. So if I take and I draw any triangle and I were to just enlarge this, we would know that each of these corresponding angles would still be the same, and we would also know that the side lengths are what we're going to say are proportional. In other words, if this is A, B, and C, and this were X, Y, Z, the proportions of A over X would equal B over Y, which would equal C over Z. That's what it means to be similar triangles. Something you notice here, in this case I kept all of one triangle on top, all the other triangle on bottom. You could flip it. You could say X over A is equal to Y over B. The only thing that's important is you keep your small triangle on top consistent or your big triangle on top consistent. In other words, A, B, and C are always on the same side. X, Y, and Z are always on the same side. You're not flip-flopping those. We can use these to take a look at practical problems, and this is something that shows up a whole lot, both in OGT, ACT, and all these, a bunch of other standardized tests. What it's going to be is we're going to say, here's a person, John. In this case, John is 6 foot 2 inches tall. I'm going to put that all in inches, makes my life a little bit easier. So that's 74 inches. He's standing outside and he's casting a shadow that's 8 feet long. In this case, his 8-foot shadow is going to be 96 inches long. Now, he's next to a tree. Let me draw my little happy tree here. Obviously not drawn to scale or drawn to prettiness. Most trees don't look that awkward. But he wanted to figure out how tall this tree is. We'll call that H for height. Now, he measures the tree's shadow to be 27 feet 4 inches long, which, another way, is 328 inches. Well, what we can assume is that the sun, in this case, since it's really far away, the sun will be hitting John and the tree at the same angle, which means the angle from John's head down to the tip of his shadow and the angle from the tree down to the tip of the shadow will be equal. Also, it's fair to say that both of these would be right triangles because for the most part, John and the tree we're going to assume are heading straight up, which means these two are similar, which also means the sides are proportional. So we can say H over 74, those are the corresponding parts, will equal 328 over 96. I'll multiply by 74 to solve to get H equal to 252 0.83 repeating feet. which is another way of saying 252 feet and 10 inches. Pretty tall tree. There are two triangles that are going to keep showing up, which all students of trigonometry, you just need to know. They're going to show up again and again and again and again. And we kind of look at, what we're going to look at is how the sides are proportional. No matter how big they are, the proportions of these two right triangles always hold. First of all, I've given away some information for saying that they're right triangles. The first one is what we call a 45, 45, 90 triangle, which means the angles are 45 degrees, and 90. To figure out what the side lengths in relationship to one of we're going to go back to the isosceles triangle thing that I pointed out earlier. When angles are equal in an isosceles triangle, that makes the side lengths equal. So both of those are going to be x, which is nice to know. As soon as you have a 45, 45 triangle, you know you have two congruent side lengths. The next one we can figure out using Pythagorean's theorem. If we call this distance c, we could say that x squared plus x squared would equal c squared, which means 2x squared would equal c squared, which when you square root of that would be the square root of 2x equals c. So the proportions for a 45, 45, 90 triangle are always x, x, and the square root of 2 times x. Now, x can be anything. If we plug in a 3, we'd have 3 and 3 times the square root of 2. If you plugged in square root of 2, you'd have square root of 2, square root of 2, and 2. But what happens is the proportions are always the same. They always are equal. In a 30, 60, 90, which is our other special triangle, 30, 60, 90, 1 degree is 30, 1 degree is 60, and obviously the other one's 90. In this case, our proportions, there's 3 of them. We're going to call one side x, one side the square root of 3x, and one side 2x. What's helpful to remember is that opposite of your smallest angle is going to be the smallest side, in this case x. Your second smallest angle, in this case 60, is going to have the second smallest angle, side length, square root of 3x. And opposite of that 90, your hypotenuse is going to be the largest, 2x. So there it is, your 30, 60, 90 and its proportions, your 45, 45, 90 degree triangle and its proportions, and these are things you're going to have to become extraordinarily familiar with if you're going to be a trigonometry, if you're going to be successful.